spot? Because you said something about average rate of change versus instantaneous rate of change. So let's remind ourselves what those two things are. So right up here at the top, average rate of change. See, that was not on this test. I think that was on the last test. It was first unit, but we still bring it back once in a while. What's the average rate of change? Either in a formula or just concept? What's average rate of change mean? Barrett? Okay. You're thinking like being specific to like speed and velocity and that kind of stuff. But more generically even? Change in y over change in x. y2 minus y1 over x2 minus x1. Sometimes we just call it the algebra slope. As opposed to the instantaneous rate of change. I'm just going to abbreviate that to instant rate of change. That you don't get 2 points. You don't get to go from point A to point B. That is the immediate dy dx. That's the derivative. That's the calculus slope. Okay, so let's, I don't want to say set that aside. We're gonna need that in a minute. I guess set it aside in your brain, but not too far aside. We're going to come right back to it pretty quick when we talk about the mean value theorem. Okay, suppose you drive 72 miles in 1.2 hours. What was your average speed? So you went 72 miles in 1.2 hours. Will definitely be miles per hour. I feel like we should have just picked something easier, but 72 divided by 12 is 6, so this is 60 miles an hour. Average speed, 60 miles an hour. Does that mean you drove 60 miles an hour for the entire drive? No, you guys have driven a little bit. Like, no, if you went 72 miles in 1.2 hours, your average speed was 60, but you didn't go 60 the whole time, probably. Does it mean that at some time during your drive, you were driving exactly 60 miles an hour? That's like, what's the case for no then? If you say no, what do you?
We driving like 61 half the time, or like 59.
Okay, that's a great answer. It's not quite right, but it's a good answer. So if you're thinking no, you're right. You go 61 half the time, 59 half the time. Your average is 60. Good. But why doesn't that work? Yeah, at some point, because you can't jump from 59 to 61, right? I mean, it's pretty quick, and you get there pretty quick, but at some point you would have gone through 60 miles an hour. So the answer is, at some time, yes. Maybe a lot of times, maybe just for a brief moment, but yes, at some point you had to have been going 60 miles an hour. In fact, I feel like we left out a word here, could there have been more than one time during your drive that you were going exactly 60 miles an hour? That one's more obvious. Like, yeah, definitely. If you were speeding up and slowing down and speeding up and slowing down, you could have been going 60 miles an hour a lot of times. But there must have been at least one time where here's back to where we started, where your instant speed was equal to your average speed. This is the mean value theorem. In short, your MVT means that your instant speed equals your average speed at least once on the interval. I don't know how, I don't want to really write all of that, but we'll just say at least once. So it has to happen. It doesn't mean it happens the entire time, but it has to happen at least once, where your instant speed is equal to your average speed, or your calculus slope is equal to your algebra slope. Where f prime, and usually we say at c because we don't know where it happens. It's not at x, it's not everywhere, but somewhere your f prime, and I can't really tell that's a prime, your f prime is equal to y2 minus y1 over x2 minus x1. Somewhere. So somewhere your overall speed equals your instantaneous speed, somewhere is equal to your overall speed. So here's where we started with, average rate of change, delta y over delta x, that's the algebra slope. Instantaneous rate of change, slope of the tangent line, dy dx, slope at a point. All those words mean kind of the same thing. Be careful using abbreviations. Like, I'll know what you mean, but will an AP grader know what you mean? Maybe, but maybe not. And if, college credit is riding on the line, don't assume they know what AROC and IROC mean. Like, you can abbreviate it close enough. Average rate of change, instant rate of change. So be careful with abbreviations, especially on the AP test. Okay, so here it is said differently or said again. The instant slope equals the average slope somewhere. Let's draw a picture and see if we can make sense of this graphically. Picture doesn't have to look exactly like mine, but it should probably look kind of close to that. So somewhere down here at the start, or close to the start, we'll have the point A, comma, f of A. And then way over here somewhere we can do point B. And its y value would be f of b. And we're trying to claim that the instant slope, or the calculus slope, is equal to the algebra slope. Let's see, the calculus slope would be f prime of x. Right, that would be the instantaneous slope somewhere along the curve. Right, the tangent line slope. The algebra slope, that's a little bit easier. That's a good old slope formula from 8th grade. F of b minus f of a over b minus a. There's our algebra slope. Let's see if I can. There's our average rate of change. After I just said be careful with abbreviations, I'm going to use one. There's our average rate of change. But we're claiming that somewhere the calculus slope should be the same. So I put my parallel popsicle stick, and it looks like it happens like right about there, where our calculus slope matches our algebra slope. Somewhere, and it happened right here, usually we call that point C. Somewhere the instantaneous slope equals the overall slope. So So this getting into the details of the calculus stuff, but don't forget that this all comes from or is related to, if your average is 60 miles an hour, then that means somewhere along the path you went 60 miles an hour. If the average slope is whatever that is, maybe that's just 1, then somewhere in there the instant slope was 1. There.
So for these, we're looking for the same slope and not like an overlap of the two curves?
Correct. Trying to find where the slope is the same. Well, I mean, that's pretty much left a little bit of space there because I need to add somewhere on A to B. Somewhere between the endpoints, the calculus slope will equal the average slope. Kind of glossed over something, and I wonder if now would be a good time to talk about it. This, given the right conditions, we almost talked about it earlier when Will suggested if we went 59 half the time and 61 half the time, that would average to 60. And then we decided, like, no, because you can't really jump from 59 to 61. So what's a calculus word that means you can't really jump? What's that? Continuous. So it has to be continuous. It has to be continuous. And continuous on that entire interval. So it has to be continuous everywhere. No jumping around. And this one's maybe less obvious, although we could draw some pictures where it would become more obvious. It has to be differentiable. On that same interval. The continuous is on the closed, the differentiable is on the open. That fine a distinction doesn't really matter for the AP test. They're never going to test you on the difference between those two. But technically, the continuous is on the closed interval, the differentiable is on the open interval. Yeah, because a cusp would mess this up. Right, if we think about my path here, if it wasn't smooth, then it would be possible for the calculus slope to not equal the algebra slope if it wasn't smooth. But if it's smooth, then it's got to happen somewhere. Okay, so what in the world? How do we use this? A car that is equipped with an easy tag drove through a toll booth at mile marker 226 at noon, then through a toll booth at mile marker 326 at 1:15. The speed limit 70 miles an hour. A few days later, the driver received a speeding ticket in the mail. How did he get caught speeding? Should this hold up in court? So let's figure out what his average speed was. So that's change in y over change in x, or I guess for this one it's change in distance over change in time. Get his average speed. So the mile markers help us figure out distance. So we went 100 miles in how many hours from noon to 1:15? So this is going to look weird. I don't know if I should even write this, but 1:15 minus noon. So how many hours is that? 1 hour and 15 minutes?
12 to 1:15.
1 hour and 15 minutes?
It's an hour from 12 to 1 and an hour from 1 to... Oh, I'm stupid.
How about 1.25 hours? pick the weird one. 100 divided by 1.25. You can trust me, that's 80. 80 miles an hour. So that means his average speed was 80 miles an hour. That means somewhere, at least one spot in between those two toll booths, he was going 80 miles an hour. So how did he get caught speeding? Well, the county or whoever sent the speeding ticket knew the mean value theorem. Should this hold up in court? Yes, as long as the judge knows calculus. I don't know what the odds of that are. I don't think they do this, because if they did, there'd be a whole lot of people getting a whole lot of tickets, is my guess. Right? On the Beltway, you're flying around, and I'm sure your easy tag gets timestamped, so they could definitely do this, but it would probably just cause such an uproar that they don't bother with it. Or they don't want to try to teach calculus to people who are going 90 on the Beltway. Okay, mean value theorem, try to put it in a box that makes it simpler. If f of x is continuous and differentiable, there must be at least one number c in the interval a to b such that, here it is, the calculus slope equals the algebra slope. So for at least one value, dy dx equals delta y over delta x. That's fine. My best way to remember it, or how I like to remember it, is that the calculus slope equals the algebra slope. Somewhere, my tangent line slope will equal the overall algebra slope. Function must be continuous, must be differentiable, and then c has to be between a and b. We have to find c, we will find c in between a and b. There's at least one spot where the calculus slope equals the algebra slope. Okay, an example, like how in the world do we use this? If g of x equals x to the 2/3, find all values of c which satisfy the mean value theorem on 0 to 8. Okay, well, before we can use the mean value theorem, we have to state that it's continuous and differentiable. Well, it would help if we knew what x to the 2/3 looked like. Well, we can do this graphically, or we could do this with an equation. I guess I'll just do it both ways. X to the 2/3. If you plugged in a negative number, it would work because you could square it and then cube root it, and you'd still get a positive number. So the graph looks something like that. That should be symmetric, but something like that. So we'll see this is like a checkbox situation. Is it continuous on 0 to 8? Who knows? 8's out there somewhere. Yeah, definitely. Is it differentiable? Let me pause right there. Is that graph everywhere differentiable?
No.
Why not?
There's a cusp
There's a cusp at
at 0.
0. Is it differentiable on the open interval 0 to 8? Yes, because that cusp is not in our interval. Like, just barely, but the parentheses mean don't worry about the endpoints, so we don't have to worry about that cusp. So now we can say that MVT applies. Maybe we should specify this. The only cusp is outside our interval. Just barely, but not in the interval. Therefore, our little 3 dots, MVT applies. when I'm doing an MVT problem, I start all the way back with calculus slope equals algebra slope. Some people will memorize the formula, but like I already know the calculus slope, I know what that means, I know what the algebra slope means, so I like to just start all the way at the top. MVT means calculus slope equals algebra slope. So the next line would be f prime somewhere, so that's what we're looking for, is equal to, I guess we could plug in 8 and 0, f of 8 minus f of 0 over 8 minus 0. Just the algebra slope. So here's my algebra slope. So I need to find f of 8 and f of 0 so that I can find my good old algebra slope. So 8 to the 2/3. Ooh, exponent rules. One of those is a root and one of those is a power. Which one's which? 3 is the root, right? Because the root grows underneath and the flower power goes on top. Back to your algebra stuff. The root grows on the bottom, flower power goes on top. So the cube root of 8 is 2. Root power 2 squared is 4. Zero to the 2/3, that's a lot easier because who cares, roots and powers, 0 to anything is 0. Okay, so that means 4 minus 0 over 8 minus 0, that would be 1/2. Okay, so now I've got the algebra slope down. That equals 1/2. Now I need to find the calculus slope. So f prime, let's see, power rule, 2/3 x to the negative 1/3. 2/3 x to the negative 1/3. And now I just need to, like it's easy, but I need to solve this for x. And that will tell me where my calculus slope, I don't know if my picture is to scale, so I should be careful. I can see where it happens. All right, if I put my parallel calculus slope on here, it happens right there. But now I need to figure out where there is. So I'm going to set my calculus slope equal to my algebra slope. And now I've got an algebra problem to do here. So I'm going to multiply by 3/2. Yes, sir?
How does f prime equal that, like 2/3 x to the negative 1/3?
Oh, power rule, bring 2/3 down front, decrease the power by 1. Power rule with fractions. Let's see, so if I multiply both sides by 3/2, by the way, we're done with calculus, we're on to algebra now, so this problem might deserve the stamp. That would be 3/4. X to the negative 1/3. How do I don't like that. I'd rather write it as 1 over the cube root of x. Well, I don't know. Either way, if you're more comfortable with powers, then you could work with that. If you'd rather see it with the root, that's fine too.
He's 64 over 27.
It would be 64 over 27 because I'm going to flip both sides, and then I'm going to cube both sides. And that would be a safe stop, but yeah, that's 64 over 27. And then my final last check is that on 0 to 8? Question mark? 64 over 27? Yeah, I don't know what it is, but it's what, 2 and a little bit? So yeah, that's between 0 and 8. 2 point something. Which means my picture is not bad. So that spot we found is 64 over 27, where the calculus slope is equal to the algebra slope. So MVT problems are kind of tricky because there's so much going on. You have to state that it's continuous and differentiable. Then you have to do an algebra problem and a calculus problem, and then set your calculus problem equal, or your calculus answer equal to your algebra answer to figure out where it happens. So there's some setup stuff, and then algebra problem, calculus problem are equal to each other. Figure out where that happens. Questions on that one? Number 2. If h of x equals x plus 2 over x minus 1, how many values of c are guaranteed by the mean value theorem between 0 and 3? Well, my initial answer is 1, like the mean value theorem guarantees 1 value. But maybe we need to pause and check on this thing. Is this thing continuous on 0 to 3? Why not? With the vertical asymptote at x equals 1, that's on my interval. So we're done with this problem. MVT does not apply. We like those. I guess we need to answer the question, how many values are guaranteed by the MVT? Well, if MVT doesn't apply, then no values are guaranteed. Because we weren't allowed to use MVT. Because that thing was not continuous. What if it had said on the interval 3 to 7? Would MVT work there? Yeah, because the only issue is at 1. So as long as we were away from 1, we'd be okay. So be careful. The interval matters. You can't just look at this and be like, whoop, vertical asymptote can't work. Like, no, it depends on what interval we're talking about. Number 3, find all values of c guaranteed by the mean value theorem for y equals cosine of x on 0 to 4 pi. Okay, is it continuous on 0 to 4 pi? And is it differentiable on 0 to 4 pi? Do you remember what the graph of cosine looks like? Even roughly, you don't even have to be perfect. Yeah, I see a few of you doing this. Like, yeah, it does that. Let's see, 0 to 2 pi, it looks like that. So 4 pi is going to be one more cycle of that thing. So yeah, just because it's cosine, it's continuous, and it's differentiable. Therefore, MVT applies. Again, I start all the way back with calculus slope equals algebra slope. If you want to jump in 1 or 2 steps down the road and say f prime equals y2 minus y1 over x2 minus x1, that's fine. But my brain thinks MVT, calculus slope equals algebra slope. So calculus slope, that's f prime or dy dx. What's the derivative of cosine? Guess I'm going out of order on this one. I'm doing or different order than the last one. What's the derivative of cosine equal to? Negative sine of x In my algebra slope, I'll need to do a little work over here. From 4 pi to 0. Let's see, cosine of 4 pi. Maybe we should do cosine of 0 first, that'd be easier. So what's the cosine of 0? 1. And how about the cosine of 4 pi if we go all the way around twice? Also 1. So I want to know where negative sine of x equals 0. Okay. Remember, we set it up. We checked if it would work. We did our calculus problem. We did our algebra problem. Now we set the two equal to each other. Sine of x equals 0. Let's see. I'm thinking back to the unit circle. Where is the sine equal to 0? Zero. And where else? And 2 pi and 3 pi and 4 pi and 5 pi and but I need to be careful though, because we're only allowed to look, or our answers are guaranteed. So MVT applies on 0 to 4 pi. Our answers have to come between 0 and 4 pi, but not including the endpoints. So I throw out 0, I throw out 4 pi and 5 pi and anything past that. So my only answers are pi, 2 pi, and 3 pi. Because we're only allowed to look between 0 and 4 pi, and we're not allowed to use the endpoints. So looking at our picture here, there's my algebra slope from end to end. And then my calculus slope is 0 at pi and 2 pi and 3 pi. Slope equals algebra slope. So continuous and differentiable, calculus slope equals algebra slope, and then solve that problem to figure out where that happens. But you're guaranteed to get an answer, at least one answer, on that. Okay, a table problem. Selected values of f and g are given in the table. F and g are both differentiable. That means f and g are continuous. That means MVT applies. Let's go ahead and knock that out. Say that at the beginning. Part A. Explain why there must be a value such that f of x equals 0. We're okay. Such that f of x equals 0. So where are we looking? How are we going to know where f of x might be 0? You see where that might happen, Emma? Between 1 and 3? This is an MVT though. This is IVT. This is a throwback question. This is an intermediate value theorem. For that one, we only need f of x to be continuous, because there's not slopes involved with IVT, so we're not worried about differentiation. We're only worried about continuity. F of x is continuous. I think we're okay to just say that because we already said differentiability implies continuity, so we don't have to state why because we already said why. So that's the first step of IVT. The second step is the y values. So f of 3 equals 5, f of 1 equals -2. The next step is the obvious, feels like dumb step. What do I need to say next?
-2 is less than 0.
Yeah, 0 is in between those two. Yes, it is. Which means I can make a conclusion about the x values. There is an x between 1 and 3, got to include that, where f of x equals 0. So that was IVT. Part B. Explain why there must be a value of x between 4 and 9 such that g prime. That's kind of a giveaway that this is probably an MVT problem because we're talking about slopes rather than values. So that's a pretty big hint. Okay, so continuous on 4 to 9 and differentiable on 4 to 9. Both of those were given to us. Well, sort of. I guess the continuity wasn't given, but differentiability implies continuity. So MVT applies. MVT means calculus slope equals algebra slope. Okay, calculus slope. I don't really have a formula or an equation to take a derivative of. So the calculus slope I'm just going to say is g prime of x. I don't really know what else to do. The algebra slope, that's g of 9 minus g of 4 over 9 minus 4. So now I'm just looking back at the table to figure out what g of 9 is. And g of 4 is, can't fit it all in my picture all at once here. G of 9 is 12, g of 4 is 7. 5 divided by 5 is 1. Oh, that's what we were trying to say. That the derivative of g is equal to 1 somewhere on 4 to 9. Don't know where because we don't really know what that graph looks like. But the average slope was 1. That means the instantaneous slope has to be 1 somewhere. Let's pass on C because C uses a trick that I don't think they do on the AP test. They don't do this trick on the AP test. All right, so your assignment is going to be worksheet 1, which I'll give you in a moment. Calculus slope equals algebra slope, and then do the math.